Assalamualaikum and hi everyone. Today I will be introducing to you our project for BERC1313 Programming Fundamental. Our project title is Electronic Component Calculator. So, in this video, we will explain how to calculate resistor value using color codes. Next, Ohm's law computation for voltage, current and resistance. After that, how to calculate the capacitance for series and parallel configuration. So, let's get started. So this is the team members. Me, Nurulain Sofea binti Hisham. Next, Aieenna Illeeya binti Nurzana. Muhammad Razmer Ar-Ridzwan bin Muhammad Rosli. Muhammad Faiz Adni bin Muhammad Yusri. And last, Tengku Razin Danishputra bin Tengku Razali.
Hi, my name is Muhammad Faiz Adni bin Muhammad Yusri and my matching number is B1224104121. So today I will explain about our project background. Basically, in electrical and electronic engineering, functional and effective circuit design require precise estimate of component value. Technician, engineer and student perform repetitive calculation involving straightforward component such as resistor and capacitor on a daily basis. Both capacitance and resistance are physically quantities that need to be converted into numerical value to be evaluated. The overall resistance or capacitance of various series or parallel combination, finding the relationship among voltage, current and resistance using Ohm's law and converting resistor color codes to digits. Such calculation can be time consuming and prone error if done by hand, particularly with many parts or when frequently required for circuit design or debugging. Furthermore, it is generally impossible to maintain such a calculation in a tidy manner for ready reference or checking. This project suggests creating an electronic device to handle these issues. Next, I will explain about scope of our project. Firstly, about the resistor calculator. It enables calculation of resistance based on user input. It may include support for direct numerical input or optionally resistor color code interruption. It also supports single resistor and combination in simple network. Next, for the Ohm's law. This allows the user to calculate voltage, current or resistance when two of the three rules are provided. It also supports basic error handling, for example, insufficient and invalid input. Third, series and parallel capacitor calculator. It computes total capacitance for capacitor connected in series, which is the formula is 1 over C total equal to 1 over C1 plus 1 over C2. For the parallel, C total is equal to C1 plus C2. The input value accepted in microfarad and processed in SI unit, which is farad. Fourth, the calculation history saving. All calculation performed by the user are automatically saved. History is stored locally, for example in a text file or local database, and can be viewed at any time with the app. Include timestamp or label for easier tracking for past result. Finally, the target user is electronic students, lab technician, hobbies and engineering involved in circuit design or troubleshooting. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurulain. Today I want to present about introduction of this project. For the introduction of this project, in the world of electronic, tasks like calculating resistor value, applying Ohm law and determining total capacitance in circuit are performed regularly. However, doing this manually can be time-consuming and prone to error, especially when working with multiple components or interpreting color codes. Our calculator addresses this challenge by offering a user-friendly interface that automates this calculation. It includes features such as resistor value calculation using color code, Ohm law computation for voltage, current and resistance, capacitance calculation for series and parallel configuration, and a built-in history log to track and review past calculation. Designed with students, hobbyists, and technicians in mind, this tool bridges the gap between theoretical learning and practical application, making electronic both easier and more efficient to work in. Let's dive into how it works and what we achieve.
Assalamualaikum and hi everyone. My name is Tengku Razin, Danishputra binti Razali, metric number B12241049. In this video, I'm going to explain the flowchart for the simple electronic part calculator program. This allows a user to perform basic calculation. So the first one is register color code. For the register color code function, the program helps to convert color band into resistance value. There are three input: the first band, second band, and the multiplier. They are converted to the number and then we calculate using the formula open bracket B 1 times 10 plus B to close bracket multiplied by 10 to the power of multiply. For the example, if the color code represents 4, 7 and a multiplier of 2, the result would be 47 4000 ohms. After the calculation, the result is displayed on the screen and saved into the history file. Then the user will return to the main menu to choose another option if need. Next, Ohm's law. In Ohm's law section, the user can choose to calculate either voltage, current or resistance. If the user select voltage, the formula used is V equal I times R. For the current, it is I equal V divided by R, and for resistance, it's R equal V divided by I. Once an option is selected, the program asks for the required input value, does the calculation and display the result. This function makes it easy user to apply Ohm's law without doing the math manually. After that, the user turn to the main menu.
Assalamualaikum and hi, my name is Mohd Ar-Ridzwan from Rosli and my metric number is B122410482. I will explain the flowchart for a function called calculate capacitance. This function used to calculate the total capacitance of multiplied capacitors. The function begins by prompting will give a question to user, how many capacitors, and then program will scan the number of capacitor to be calculated. Next, program will ask the user to input the value of each capacitor in microfarads. After collecting all the values, the program will display a menu asking the user to choose the type connection, either series or parallel. If the user select a series, the program calculates the total capacitance using the formula 1 over C1 plus 1 over C2 and so on. So and then if user choose the parallel connection, the capacitance will calculate by using the C1 plus C2 and so on. Once the calculation is done, the program display the total result and end the function by returning control. Okay, for the second flowchart that I will explain is save to history. The flowchart explain how the functions work. So the function is used to save some text into a file called history.txt. It starts by trying to open the file using the fopen function. If the file opens successfully, the program will continue and returns normally. But if the file cannot be opened, it shows an error message to the user. Okay, for this flowchart, shows the overall structure of a program that starts by displaying main menu with the different options. The user can choose to calculate resistor value by color code, apply Ohm's law, calculate total capacitance, or save text to a history file. Based on the user selection, the program checks each option one by one. If the user choose to calculate resistor by color, the calculate resistor by color function will run. If not, it check for Ohm's law, and if selected, it runs calculate Ohm's law. If not, it move on to check capacitance calculation using the calculation capacitance functions, and finally checks if the user wants to save the data using save to history in bracket char text. If none of these options are selected, the menu will display again. After completing any of the chosen functions, the program will end. This flowchart help organize the program so that the user can easily access different calculator features in a structured way.
Hello, my name is Nurulain Sofea binti Hisham, and my matrix number is B12241047. Today, I will explain about the output program of the calculate the resistor by color. So, the first function that we create in this program is called calculate resistor by color. This function is designed to calculate the resistance value of a resistor based on the color bands entered by the user. As we can see, starting at line 45, we define the beginning of this function. Then, in line 46, we declare three integer variables, which is B1, B2, and marked, to store the value of the first band, second band, and multiply band respectively. We also declare result, which will store the final calculated resistance value. Next, in line 49, the program displays a list of color codes along with their corresponding numbers. This helps the user know which number represents which color. Next, in line 50 and 51, the program prompts the user to input the first color band and store it in B1. Similarly, line 52 and 53 prompts the second color bands, which is stored in B2. Then, line 54 and 55 ask the user to enter the multiply bands, and that value is stored in marked. Moving on to line 57, this is where the calculation takes place. The formula used is first band multiply 10 plus second band, and multiply 10 to the power of multiply, which follows the standard resistor color code rules. In line 58, the calculated resistor value is displayed in ohms. Finally, from line 60 to 62, we declare a character array named line to store the result as a formatted string. This string is the save used to save to history function, so user can review their past calculation later. So that is the coding for our function. Next, I will explain the output of this function. To begin, the user is prompted to enter the color bands of a resistor. For this example, I enter 1 brown for the first band, 0 black for the second band, and 3 orange for the multiply band. Based on these inputs, the program calculates the resistor value. The combination of these color bands, brown, black, and orange, correspond to a resistor value of 10,000 ohms or 10 kilo ohms.
Assalamualaikum and hi everyone. Today, I would like to present in the Ohm's law calculation feature from our electronic part calculator. So let me examine the calculator Ohm's law function. This function presents the user with three calculation options. Takes the input value based on the selected calculation, computed that the result using Ohm's law formula, display the output with the proper unit, save the calculation to history. The function begin declaring variable for the voltage V, current I, and resistance R. It present a menu with the three options: voltage calculation V equal I times R, current calculation I equal to V divide R, resistance calculation R equal to V times R. R equal to V divide I. In our first example, the user selected option to calculate current voltage 500 volt 50 volt, resistance 10 ohmega. The function computed the current is as 5 ampere, 5.00 ampere using I V equal V divide R. So in the second example, the user choose option 3 for the resistance calculation. Voltage 5 volt, current 5 ampere. The function calculate resistance as 1.00 ohmega using R equal V divide I. Arrow handling slide. The function include the basic arrow handling. It is a validate the menu selection, the prevent division by the zero in current divide resistance calculation. Return early for the valid choice. Is history slide after each calculation. The function format the result in a string and call the save to history. All user to review past calculation through option 4 in the main menu. This Ohm's law calculator demonstrates clear user interface with prompt, proper unit handling, accurate calculation, history tracking. It is a practical tool for the quick electrical computation in both educational and professional setting.
Hello, my name is Faiz bin Yusri. My magic number is B122410421. So today I will explain about the calculation of the capacitance. So first of all, as you can see at the line 103, this is the start of the function that name the calculation capacitance. For the line 104 to 106, that the declare of the variable of the which is n is the number of the capacitor, I is for the load counter, type is the user selection, which is 1 is series, 2 is parallel, cap 10 is array to store capacitor value, that maximum for 10 capacitor, and then lastly the total is the store the final total capacitance. Next for the line 108, which is printf, how many capacitor, which is that will ask the user for the number of the capacitor that used. Next the line 109, which is scanf, that will read the user input into variable. Next the line 111 to 115, that the function is the loop to input value for each capacitor from the user. That's also store each value in the cap array. Next the line 116 to 117, which is the printf and scanf. This function is to ask the user to choose type of the connection, which is 1 for series and 2 for parallel circuit. Next the line 119 to 123, which is the series of the capacitor. For the series connection, we use the formula 1 over capacitor total, which is 1 over capacitor 1 plus 1 over capacitor 2. Next for the lines 124 to 127, which is for the parallel. For the parallel function, we use the formula C total, which is C1 plus C2 and so on. Next the line 128 to 130, that is the invalid type, which is we use else and printf. So if the user type the wrong number, the program will print the error and exit. Lastly, for the lines 132 to 134, that the function of save and print of the result, we use the char, which is line 100, printf line capacitance, so that will save the history. the format of the output into a string, so that use ternary operator to choose series or parallel. So this function called save to history to record the result. Next, I will explain about the output of the program. So first of all, the user need to insert the value of the capacitance, which is the first capacitor is 5 microfarad and the second capacitor is 5 microfarad. Next, the user need to choose the connection of the circuit, number 1 for series and number 2 for parallel. So for this output, the user use the number 2, which is the parallel, so the program will calculate the capacitor, and the total capacitance is 10 microfarad. So for the second run, we use the same value but the different type of the connection, which is number 1, which is the series connection. So the program will calculate and the total capacitance is 2.5 microfarad. So that's all for me. Thank you.
Hello, my name is Nurulain binti Nurzana. My metric number is B122410478. Today I want to explain about output program for the read history. So today I want to explain about the read history for this coding. Okay, for the line number 141, this void save to history char text. This define a function name save to history to that makes one parameter appointed to a character array char text, which is typically a string containing calculation result to be saved into a file. For the line 142, file f open history text. Open the file history text in append mode A. F open return a file pointer f, which will be used to write to the file. If the file does not exist, it will be created automatically. Append would ensure that new data is added to the end of the file without deleting previous contents. For the line 143 until 145, if null, check if the file failed to open. If f is null, that means f open couldn't open or create the file. In this case, an error message is printed and the function exists yearly using return. For the line 146, f prints text, write the contents of the string's text into the file. Printf is similarly to printf, but it's print to a file instead of the script. For the line 147, f closes the file to ensure that all data is properly saved and system resolved and released. For the line 149, void read history begins the definition of a function called read history. The function does not take any parameters and is used to read and display the contents of the history text file. And the line 150, open the history text file in read mode R. This means the file is only open for reading and no writing is allowed. For the line 151, char line 100, declare a character array string named line with a size of 100 characters. This will be used to store each line read from the file. From line 153 until 155, printf no history found written. Check if the file could not be opened. If the file doesn't exist and it increasable, it prints not history found and exits its function. For the line 157, printf prints a heading to separate the history section visual on the screen. For the line 158 until 191, while f gets line size of line, printf line, this while loop read the file line by line using fgets. Fgets reads one line at the time and stores it in the line array. Printf then display each line on the screen. This continues until all lines in the files have been read. For the last one is line 162, fclose. It means close the file after reading to release system resource. Thank you.
Assalamualaikum and hi. My name is Mohd Ar-Ridzwan bin Rosli. My metric number is B122410482. Today I will be presenting our full coding for our project, and I will also simulate this coding. So here our full coding. This is our function. So this is for the first function, which is calculate the resistor. The second function is this one, calculate Ohm's law. The third function is calculate capacitance. And the fourth function is save to history. Okay, now I will run this coding. So we get here 5 choice. First, resistor, Ohm's law, capacitance, and we pass calculation, and the last one is exit. So we go through with the first choice is resistor. So this is the color band, so we must put at here. Enter the first band, such as we try 10 kilo ohm. So for 10 kilo ohm, the first band is brown, and the second band is black, and the multiplier band is orange. So we get the 10 kilo ohms. So we go through with the calculate Ohm's law. So we must put, enter your choice is 2. So in Ohm's law function, we can calculate the voltage, current, resistance. So we go to calculate the voltage first. So we put 5 ampere. The resistor we put 10 kilo ohm, and we get the 50,000 volt. So now we calculate the current. We choose 2. The voltage is 50,000 volt. The resistance is 10,000. So we get the 5 ampere. So we go to calculate the resistance. The voltage is 50,000 volt. The ampere is 5, and we get the 10,000 kilo ohm. So we go to the number 3 is calculate the capacitor. How many capacitor? We put 2 capacitor. So the first capacitor, we put the easier number 5. So we put series, and we got the answer. Now we try to choose a parallel. 2, 5, and then parallel, and we got the answer. So for choice number 4, view past calculation, and we choose 4, and we get the history calculation, all of this, and we get here. So if we done to calculate everything, we choose exit number 5, and then yeah. But if we put the wrong input, such as number 6, and we get the invalid choice, enter the correct input. Yes, that's all from me. Thank you.
So, for the conclusion is, the development of the electronic components calculator successfully fulfills its primary objective of assisting user with fundamental electronic calculation by integrating functions such as resistor value computation through color codes, Ohm's law calculation, and capacitance determination for both series and parallel configuration. The program streamlines routine tasks encountered in circuit analysis and design. The inclusion of a history-saving feature further enhances its usability, allowing user to track and review past calculation effectively. So that's all for our group. Thank you.